Hello, this is Mr. Flatness, and today we're going to be combining two sections of Chapter 2, both sections 2 and 3, adding and subtracting real numbers. We'll start out our notes tonight by writing down the rules of addition. There are two that are of importance for you, so go ahead and write these down in your notes with the examples. And then I will explain them as you go, again utilizing the pause feature whenever you need to. We will start out by taking a look at adding two numbers with the same sign, and specifically thinking about this quickly, all you need to do is if you see two numbers you're adding with the same sign, you simply just need to add up those numbers and then keep the sign that you see. So in our example of -4 plus -5, both have the same sign. So basically we're adding their absolute values that we just learned in the previous lesson. So that would be 9, and then I'm going to keep the sign that's negative. The second rule that we'll look at is adding numbers with opposite signs. And so taking a look at an example here, what we need to do is take a look at the numbers, find their absolute values, and then we're going to subtract the smaller absolute value from the larger one. So in taking a look at 3 plus a -9, I'm basically going to take 3 from 9 to get 6, and then I'm going to keep the sign that has the larger, so I have more negatives here in 9. Okay, so then that would be -6. The next slide we have are all the properties of addition. These properties you've seen before. In fact, you've seen them all the way back into the 6th grade. Where we had to identify properties with examples. So we're going to write these down in our notes again. We want you to write down both the algebraic model, which you see here on the left-hand side, as well as specific examples, so that looking at these you can really start to have these memorized, and you can apply these things and know what they look like and then be able to put a name to them. So we'll start out with the commutative property of addition, which is simply the order of the numbers that you add. Doesn't matter, it will not change the sum. So looking at the algebraic model, a plus b has to be the same thing as b plus a. And then here's the specific example to write down. We're both going to get +1 when they add those two numbers together. So the big word that I think we can take a look at here with commutative property, because when you look at our second property, associative, these two properties are what students mix up from time to time, and so the major difference between the two is simply the commutative property specifically talks about order. Okay, and that's the big thing. All we're doing is changing the order. Where when you look at our next property, the associative property, now we have a little bit more to it. Looking at our algebraic model, we have a plus b in parentheses, which means order of operations means we need to take care of that first, and then adding in c. We're going to know that that's going to be the same as adding b and c together first and then grouping in a. So basically what we're saying here is the way you group three numbers when adding will not change the sum. So taking a look at a specific example, on the left-hand side of the equal sign that you see here, I'm grouping the -5 and 6 together first and adding in the 2. Where on the right-hand side, I'm grouping the 6 and the 2 together and then adding in the -5. And then looking at both sides, to me there's one easier way to add up in my head, and that would be -5 plus 6 is 1 and 1 plus 2 is 3. That goes a lot quicker in my brain than trying to take 8 plus a -5. So that's why the associative property is an advantage. So again, commutative property, we're talking about order. But the associative property, we're going to be talking about grouping. And that's how you keep the two different or separate in your head. The next property we have is called the identity property. And that's going to be basically the sum of any number that we have, and 0 is going to be the same. So our algebraic model, any number a that I have, if I add 0 to it, a will keep its identity. It'll stay the same. So -4 plus 0 stays -4. Pretty simple to think about. And then the final property of addition that we have is called the zero property. We can also call it the inverse property, so two names to talk about the same property. But basically, the sum of any number and its opposite is always 0. So our algebraic model, a plus a negative a is 0. Just like 5 plus a negative 5 is 0. So in looking at this slide, it is well worth your time to really dive in and try to keep these particular properties I guess memorized or really straight in your head so that you can pick them apart by looking at any type of example, because if you know these properties, computation goes that much quicker. So now that I know a bunch of properties using addition, I can use those properties to make computation go very quickly in my head. So in these four problems that we have, we're going to apply the properties to check the answers that they give us. So in problem number 1, we're going to add negative 7/10 plus this quantity of 1 9/10 plus 7/10. And they are saying that the answer right now would be 1 9/10. Notice they have grouping symbols. They're grouping 1.9 and 0.7. So if I were to simply use the order of operations, I would have to add those two first and then add in the negative 7/10 to see if 1 9/10 was correct. But if you recall, because we have all addition here, I know that I can regroup the terms differently so that I can come up with a problem that will give me the same answer, and it can go much quicker. So that property that I would want to use then, changing grouping symbols, would be the associative property. So instead of grouping 1.9 plus 0.7, I notice here I have a negative 0.7 or negative 7/10. So to me, I know that that would be the inverse property. A number, negative 7/10, plus its opposite, which we have is going to be plus positive 7/10. That equals 0. And then I'll add into it the 1 9/10 that is remaining or left over. Now I have 0 plus a number, which is the identity, because I know that 0 plus anything is itself. So my answer then is 1 9/10. So I was able to use a couple different properties to check to see if 1 9/10 was actually accurate, and it is, and I was able to do it very quickly in my head because I knew about the associative property as well as the inverse property of addition. And finally, actually, I also used the identity property. So I used 3 properties on this particular problem. In problem 2, we have negative 3 plus a third plus 2/3 is equal to negative 2. And so I can again look at checking if negative 2 is the answer by simply adding these numbers in their order, left to right, which I can do. It would take me, or maybe other people, somewhat of time to take negative 3 plus a third. However, I also know about changing the order up again. So I can use another property called the commutative property to change up the order. So I'm going to add 1/3 plus 2/3 first because I can do that very quickly in my head. So using the commutative property, 1/3 plus 2/3 would be 3/3, or 1. And then I'll add into it a negative 3. And 1 plus a negative 3 would give me negative 2. So using the commutative property, I can come up and have a quick check to make sure that the negative 2 that they give us is the correct one. The final 2 problems are a little bit more simple, simply because you can just take a look at what's happening here, going on, and you can know that there's a property that fits both of these. So in problem number 3, you see a number plus its opposite, so you should know that that's the inverse property or the 0 property, whichever one you want to use or say. So I guess I prefer inverse, but that's just me, the inverse property of addition. And then finally the last one that you see here, 8 plus 0 is 8. So the number 8 is keeping its identity. It's staying the same, so obviously that's the identity property. So knowing these properties are very, very important. It makes math go that much faster in your head. So please study these, know these inside and out, because it can make computation a lot more simple. Let's take a look at one more example. Okay. Now you could press pause right now and try use some properties and add this up in a way and see if you get a plan of attack that's similar to mine or not. So I'm going to begin here by looking at the problem. This expression here is 3 2/10 plus 4 plus negative 1/10 plus negative 4. So looking at this, I don't see any grouping symbols. I do see a number and its opposite. I see 4 and negative 4. So I think I'll simply switch up the order. So I'm going to rewrite this problem as 4 plus a negative 4 plus negative 3.2 or 3 2/10 plus negative 1/10. So now that I've used the commutative property to change up the order, I can use the inverse property to know that a number plus its opposite is 0. And then I can take negative 3 2/10 plus negative 1/10. And again, I can change up the order. I can add these two together first, add up my negatives. So then 0 plus a negative 3 2/10 plus another negative 1/10 would be negative 3 3/10. And finally, I know that any number plus 0 would be itself, the identity property, so my final answer is going to be negative 3 3/10. So here I used two different properties. I used the commutative property to change up the order, and then I also used the identity property to get my final answer of negative 3 3/10. The next concept we're going to talk about is the concept of the subtraction rule. And I guess we can go back to last year, and you even learned this concept in 6th grade, but I would probably expect that most of you remember Mrs. Oistad and Mrs. Ostegard talking about the concept of add op. That's basically what the subtraction rule comes down to. The formal definition that we want you to write down in your notes would be this. If I'm going to subtract b from a, I have to add the opposite of b to a. So the algebraic model of a minus b would then be the same as a plus a negative b. And then the specific example that you can write down would be 3 minus 5 is the same as 3 plus a negative 5. The final concept for tonight is the concept called terms. And terms are simply parts. They're parts of an algebraic expression. So an example of the algebraic expression we have here, 3x plus negative 8 minus 4. We're just looking at the individual parts. So if you look here, we have a term that is a variable term because it has a variable in it. And then we have two more terms that are called constant terms because they will remain constant. Negative 8 will always be 8 forever. But 3x could differ from problem to problem to problem depending upon what x is. So the terms for this particular one, you'll see, would be then 3x, negative 8, and then notice here we have negative 4. The reason why we put negative 4 down here is because in the above example, remember we see a subtraction symbol in here, so I'm going to add the opposite, and so that's where we come up with the negative 4. So in the homework that you're going to receive, you're simply going to look at a bunch of expressions and you're going to have to pull out all of the terms that you see. Some more terms that we could have would involve squared terms like x squared, or cubic terms such as y cubed, p to the fourth. I mean, there's all different kinds of terms that we could be talking about. And the final thing is we'll be looking at, we can group terms that are alike, like terms. So I can add x squareds with other x squareds. So here I've got two of them, so that would be 2x squared. But I cannot group terms that are not alike. So in other words, I cannot group an x squared with an x cubed and say that that's 2x to the fifth. Okay, these are just separate terms. So there's your concept of terms. So we'll do one more. We'll do an example dealing with subtracting real numbers. So in this we have 10 minus 5 plus 14 plus a negative 18. So again, we'll think about this concept called add op, or add the opposite. So anywhere I see a subtraction sign, I'm going to change it to addition, and then the next digit that I see, I'm going to change it to its opposite. So in looking at this particular problem, I'm going to add the opposite, and then I'm going to add the opposite. So the new sentence or expression that I'm going to write would be 10 plus a negative 5 plus 14 plus 18. And then I could apply different properties to make the computation go easier in my head. So looking at the terms, I guess the easiest way that I would group them probably is to deal with 10 plus a negative 5. That's fairly easy to do in your head. There you should get 5, and then 5 plus 14 plus 18. You could simply do those in order, or you could change up the order by using the commutative property if you wanted to. To me, looking at it, it's just as easy to add 5 plus 14 to get 19, and 19 plus 18 then would be 37. So that is the answer, or positive 37, using this concept of add the opposite. So finally, here are your practice problems for tonight. Please complete these 4 different examples. Put them at the top of your paper that you're going to start your assignment on tomorrow. Complete them, and then we'll give you the answers tomorrow and discuss them along with any questions that you might have. Have a great night.